there, this is Mrs. Sharp, and if you are watching this, that means you're following directions and getting the notes for Learning Target 4.8. I just wanted to let you know that I'm going to kind of go quickly through this. It's not difficult to take the notes for this. However, feel free to pause at any time so you can catch up with the notes that you want to take. So here we go, Learning Target 4.8. We are going to understand how the periodic table is organized, including the location of metals, nonmetals, and metalloids. We are going to know the names, location, and key properties of some of the major families, and this coincides with section 4.1 in your book, so feel free to look there as well. Here's a periodic tables layout, and one thing that we would like for you to know is that metals are any elements on the periodic table that are on the left side of the stair step that kind of occurs right here by boron. This makes sort of a stair step, and I would encourage you to go ahead and write this in. And anything that is on the left hand side of there are your metals of that line, that stair step. And anything on the right hand side of that stair step we're going to call nonmetals. And that's an important differentiation for later. So just knowing that something is on the left hand side of that line is enough to tell us they're metals. So that would include these guys down here, because those actually belong squeezed in right between those two families. Hydrogen can act as a metal or a nonmetal, depending on how it feels. Hydrogen is the resident freak of the periodic table, so he kind of doesn't fit in anywhere. He sort of does his own thing, acts like his own person. Your metalloids live right along that stair-step line that I was mentioning before. So any element that sort of touches that line is known as a metalloid. So that would be boron, aluminum, silicon, germanium, arsenic, antimony, tellurium, polonium, and acetine is usually not included, but those touching the stair step are considered to be your metalloids. Your transition metals are named for those groups between 3 and 12, or your D block. Both rows in the bottom are called the rare earth elements, or the inner transition elements, and they are all metals. The top row is known specifically as the lanthanides. The bottom row is known specifically as the actinides, and that is because lanthanide directly precedes the lanthanides, and actinium directly precedes the actinides. Fluorine is the most active nonmetal on the periodic table. We're going to talk about why later, but I'd like for you to know that. Francium, down in the bottom left, is your most active metal. And remember, all metals being on the left side, that makes sense. All your nonmetals being over on this side, fluorine is over here on the right. Finally, this shaded area is known as the representative elements. So that is families 1 and 2, and then 13 through 18. They're called representative because between those 8 families, pretty much all of the properties of all of the elements are represented. So in other words, you could represent the entire periodic table by just considering these 8 families. So here's another general layout. So we've got our representative elements you can see right here, groups 1 and 2 and 13 through 18. Here's our stair step, make sure you get that down. On the right hand side are our nonmetals, left hand side are all metals. Here's our transition metals. Here's our metalloids right along the stair step. Got our lanthanides and actinides. Fluorine is our most active metal, and francium is our most active metal. So that's just a repeat. Remember, this whole F block area are called your rare earth elements. So now we want to go a little farther and talk about the properties of metals, nonmetals, and metalloids. Some of these you probably know already. So metals, remember that's everything on the left-hand side of that stair step. They are malleable, they are ductile, they have luster, they are good conductors of heat and electricity, and most become cations. Now, this is a general statement, so there may be a few exceptions to this, but in general, this is how metals behave, their properties. Nonmetals are basically the opposite. They are brittle, they are dull, not shiny, they are poor conductors, and most become anions. So brittle meaning instead of being able to be hammered into this nice sheet or pulled into this nice wire, they're just going to break, shatter. Now metalloids are kind of the junk drawer category. They're right along that stair step and they don't really know who they want to be like. They have properties of both kind of at the same time. So it's hard to categorize them as metals or non-metals because they have properties of both. Now we're going to move on and start talking about some of the families on the periodic table. You have a chart for this in your notes, so you can go ahead and just fill out your chart. I want you to know the names of these very important families and the number of valence electrons. So group 1 are called the alkali metals, and it's important for you to know that this does not include hydrogen. Hydrogen is not an alkali metal. So starting from lithium on down in group 1. They are extremely active. They are never found all by themselves. They are only ever found in compounds. That's how reactive they are. As soon as they are all by themselves, they will immediately react with somebody, so they become a compound. And they only have one valence electron, so that whole family ends in S1. Alkali metals. They always have a +1 charge, and that's because of that one valence electron. The second family in group 2 are called the alkaline earth metals. And I always remembered this in kind of a dorky way. Group 1, so group 1 has one word, alkali, just one word. Group 2 has two words, alkaline earth. 1, 2. So I know that's kind of silly, but those names are so close that that's how I remembered them. Okay, so group 2 are very active as well, although not as active as group 1. They are also never found free. They're always in compounds. And they have two valence electrons, so everything ends in S2, which means they have a +2 charge. Groups 3 through 12 are also called the B group. Those are the transition metals. They are active metals that are highly colored. So that means if you have a compound with one of these transition metals in it, most likely those are your pretty colored elements. Whereas representative element compounds are usually kind of a boring white or gray or maybe a pale yellow. The compounds of these are usually like a bright blue or a red or an orange, something like that. They have a variable number of valence electrons. It can be anywhere from 1 to 10 to 12. It just varies. And they always end in S2, D, 1 through 10. That means their charge can vary anywhere from +1 to +7. So you can't really say, oh, this one has a charge of +1, because it really, even chromium can be +2, +3, +6, or +5, I think. But chromium itself can have 4 different charges, so you really can't say what the charge of this group is like you can with the other representative families. All right, moving on to the rare earth family, or the inner transition. So these are your rare earth elements as a whole. The inner transition metals or inner transition elements as a whole. They are all metals. The top row is known as the lanthanides. We talked about that already. The bottom row is known as the actinides. Group 16 is known as the Chalcogen family. That's starting in row 16. They start off with being a very active nonmetal. Oxygen is a very active nonmetal, as it is on the right-hand side of that stair step. As you go down, however, we cross the stair step. So the stair step, remember, starts with boron and ends there. So we start with nonmetals, we move to a metalloid and then to a metallic on the bottom. They can be found free. You can find free sulfur. They have 6 valence electrons, so they're usually going to get a -2 charge. And I say usually because there are a couple of exceptions to that. And they are known as the chalcogens. Our second to last family are called the halogens, so the 17th group. They are very active nonmetals. F is the most active nonmetal on the periodic table. They are found in compounds. If they are free, remember these are some diatomic molecules. So they would be formed like Br2 instead of just Br. And they always have 7 valence electrons with a -1 charge. Remember, that's to get that 8th valence electron, so 1 extra electron. Finally, we have our noble gases. Sometimes they're called the inert gases. Inert means doesn't really do anything, and that's because they're very unreactive. That's also why they're called noble, because they don't mix with other elements, just like kings and queens were nobility. They didn't mix with the commoners. So they're nonmetals. They're all gases, hence noble gases. They can be found free as what are known as monatomic gases. Monatomic means one-atomed gases. So they are you'll never see Xe2. There's no such thing. What you would just see is one atom of xenon floating all by itself. They all have 8 valence electrons, so they have a charge of 0, except for helium. Helium ends in 1s2, so it actually has 2 valence electrons. Everybody else has 8. But helium is still considered a non-reactive, happy, noble gas because for the first energy level, it can only hold 2 electrons, and that's what helium has. So that valence electron level is full, just like all of these valence electron levels are full. So a charge of 0. So that's it for learning about families on the periodic table. I know that I'm keeping going here, but we'll do that later. So that's it for families on the periodic table. Go back and look at things maybe that went too quickly, or go back and pause things. And we'll go over a little bit more on Friday, but thanks for watching. Bye.